Unit 18, Part 2. Well done if you noticed there was a missing bracket here. I just added it. Okay, so let's see how this proof goes. Remember what the first things that appear on your page are. 1 and 2, right? And the last line. You've got the two premises. This is the conclusion down the bottom. This is what we're aiming for. Let's take note of the form of our formulas. And Klenk will stress here that it's even more important than it was before that you pay attention to the form of these things, especially with regard to, I'll say again what you're sick of hearing. You've got to pay attention to the form of the formulas so you know what rules you can apply, right? So the form of the conclusion must be grasped to know what kind of rule is going to allow you, what kind of rule is going to allow you to derive that formula, and also what formulas you need to apply that rule, right? And the form of the premises needs to be grasped to know what rules can be applied on them. If they're conditionals, you think modus ponens and tollens. Right? If they're quantifier statements, you're thinking instantiation. If this is a quantifier statement, you're thinking generalization, etc. And it's very important, she stresses, and there's a number of specific lessons to be taught about this, that you can't do UG or you can't generalize or instantiate from formulas that are not in quantified form. You can't do it on subformulas, right? You can never do an EG where you add an existential statement to the middle of the formula, right? If you do an existential generalization, it has to be by adding an existential to the very beginning of the formula, right? You can only instantiate when you can only universally instantiate when you've got a universal statement, starts with a universal quantifier, scope of the quantifier extends to the end of the formula, and you can only do it by getting rid of that leftmost universal. You cannot instantiate and get rid of a universal quantifier in the middle or anywhere except for the very beginning of the formula. And similar for existentials. Existential instantiation can only be done by getting rid of the existential quantifier which begins the formula. Klenk gives you, look at all those errors on the bottom of 343. That's what I'm talking about. Those errors are the ones I'm mentioning. Okay, so let's take stock of the form of our statements. What is 1? Is it in quantifier form? Yes. It's an existential. Scope of that existential goes to the end, right? It's an existential, and we should also notice that this I form categorical has as its second conjunct, the second conjunct of the propositional function bound by the existential quantifier. That's a universal statement. Right? Notice that, because it's probably going to pop out, right? You're probably going to do an EI, and then maybe a simplification, and then you're going to get that universal statement all by itself. Think back now to what I said when we were going through the QN rules from Unit 17, and how you work the negation through. And I said the reason why you want to work that negation through sometimes when you're doing QNs, to transform negations into quantifier form, you want to keep working it through such that when you do instantiate, the result is also a quantifier statement. So you can, instantiate, for example, on that one as well. Okay, so there's that. Our second statement is just a monadic predicate logic, categorical, A form. There's no relational predicates, right? And there's only the one quantifier, right? So very familiar with that. And this is the conclusion. These haven't appeared, right? But this is my conclusion, okay? Most important thing to cognize at the very beginning of all three formulas is really the formula of the conclusion. Is it in quantifier form? Yes, it is. It's an existential statement, right? Scope of this existential goes all the way to the end, at least it does now that I've added another bracket, as I should have before. That was missing in part 1. Okay. So so 1 and 2, another thing I have to be put in mind of, I've got an existential statement and a universal statement, right? So I have to be put in mind of the first of the two applications of hard before easy, right? The second one, the first one is do existential instantiation before universal instantiation. That's what's in play here. The second of the two applications of hard before easy I mentioned in Unit 18, Part 1. Set up for UG before doing, set up the UG subproof before doing universal instantiations. Okay? But let me, before I do, so I'm going to do EI before UI, right? And you notice I've done the EI first here, but let me get to that in a minute. Let me work backwards a bit, okay? So this isn't, what is the form of my conclusion? So I'm just thinking now, these haven't appeared yet. It's an existential. I'm probably going to get there by existential generalization, right? Now, okay, no, let me start with the universal instantiation. Sorry, the existential instantiation. So you see the wrinkle in the use of these rules with an instantiation, which is a bit simpler. Okay, so this is what it is. So there exists. So what's the first statement say? I'm going to EI from 1, existentially instantiate 1. There exists an X such that both X is a person, and for all Y, if Y is a dog, then X does not like Y. Okay, so that's true of some one individual. Now I'm instantiating, so this says what a quantifier statement say. What does an existentially quantified statement say? That the quantifier statements say that the propositional function is, they say of how many things the propositional function is true. Quantifier statements say of how many things the propositional function is true. That's their function, which is different from names, right? That's what quantifier statements do. Existential statements tell you that the propositional function is true of at least one individual. So we are instantiating what we're told is true of at least one individual to the individual Andrew. And remember, we had to limit the use of EI because it's not valid for me to infer in an unrestricted way, somebody trampled my strawberry patch, therefore you trampled my strawberry patch, right? It might not be true of that particular individual, so we have to keep Andrew, arbitrary. We have to keep that individual as an arbitrary individual. We do that by just flagging that letter and saying, oh, look out, what we're saying if true is we've gotten from an existential statement. Okay, so don't combine that with specific knowledge that's in the premise or conclusion. Remember rule 2 for the flagging rules. And don't UG over it. Okay, so anyway, we have, so now it's of Andrew. It says, Andrew is a person and Andrew doesn't like all dogs, basically. For all Y, if Y is a dog, then look at this. L, not L, A, Y. The first thing to cognize, right? So what I've done in instantiating, so, okay, doing things on 2 levels. The meaning level, right? That's talking about Andrew. We're instantiating to the individual Andrew. We're saying of him that Andrew is a person, and for all dogs, for all Y, if Y is a dog, it's not the case that Andrew likes Y. So I'm saying Andrew is a person who, this specific person Andrew, does not like all dogs. Okay, so you should be able to hear that meaning, recognize that this is an expression of that meaning, and recognize that it's fine. It's fine to have not L, A, Y. A for an individual, Y a variable, bound by that quantifier. Okay, now the mere formal, in terms of just mere formal manipulation of symbols, look at what we've done. Okay, and this is soon enough you get in the habit of doing these, you won't be processing for meaning so much, you'll just be doing this. Okay, what have I done? It's an existential statement that says something's true of X. You leave, so in existentially instantiating, same rule. What do you do in instantiating? You delete the quantifier and you replace all the variables matching that quantifier, so here, every X with the same individual constant, namely A. Now, because that's a bit trickier here, we have this new addition to the justification, existential instantiation, replacing the X with A. You do individual constant slash variable, both for these and the generalizations. This is going to be, we'll also write here A for X. Yeah. A for X? Yep. A for X there. Sometimes it's going to be B for Y, stuff like that, right? Okay. So it's E, I, A for X, flag A. A is flagged. Okay? So just notice all the Y's stay in place. It was dy. I do not replace the Y. So the two crucial things are you got to replace every X, including the X over here, all the way over here, with the same individual letter A, because it's an existential statement, right? The quantifier binds the whole thing. Wouldn't be able to existentially instantiate if it wasn't in quantifier form. You replace every X, so that one and that one, with an A, and you leave the Y's in place. You only replace the X's with A's. You leave any Y in place, including the Y quantifier, dy here, and this Y here. So you place one of the two letters in the L-A-Y and left the other one in place. It's not weird. Work through a few examples until you get familiar with it. But that's what you do. Now, just look at the form of what you've got as a result. It's a conjunction. So I simplify, and I get PA, which I'm going to want, and I also get this universal statement. For all Y, dy hook, not AY, not LAY. Okay, so that's a universal. So I can universally instantiate from that, replacing Y with an individual constant. But I'm not going to do so right away. And it's important that I don't do so right away, because I'm not quite clear or sure yet what letter I want to replace Y with. Will it be A? Will it be B? As you'll hear me say several times, a lot of the proofs in this relational predicate logic have to do with matching letters. From when you're sort of working down and working up. Matching letters, especially in the relational predicates, right? Right? Getting the X's to match the A's and the Y's to match the B's, or vice versa. You'll see a few instances of that in practice. Okay, so I've stopped there. I've done an EI, I've flagged A has appeared in the proof. Now working backwards here. Okay, so this I didn't do before. So generalization is just the opposite of instantiation, right? So if you're working backwards and saying, this is an existential statement, I'm going to get it by existential generalization. What instance, right, again, what's its form, tells you what rule, the form tells you what rule you're going to use, e.g., and tells you what formula you need to get to apply the rule, which in this case is this instance, right? And from here to here, if this was a premise and I instantiated, it would look like that. Because what we did there, you do the same thing, just working backwards, that's what's happened. I've added an X, so here working this way, the X is replaced with A everywhere, right? Yeah, so right, I've added the quantifier for the generalization, but if I was instantiating, I'd delete the quantifier, replace the X with an A, leave the Y in place, replace the X with an A, and leave the Y in place, right? So I'm working backwards, I've written this down, I have found the instance, or I've said, yeah, I've said, this is the instance I need to get. Don't know how I'm going to get this, question mark here. This is the instance I need to do the UG. Okay, just working backwards. What's the form of this? It's a conjunction, right? Okay, the form tells you what rule you're going to use to get that formula. It's a conjunction. You use conj to get conjunctions. What formulas do you need to use conj? The two conjuncts separately. Okay, so, well, hey, look, I've got one of them, tick. I've got one, PA. So all I need is the second one, which is this, which is a universal statement, okay? So basically, when I get that, I'm home free.